Hello viewers, this is the topic of equations with fractional indices. I want to make you aware of the following point. Here, the x or the variable in any of the examples is the base. When you compare that to exponential equations, in exponential equations, the x or the variable is actually in the index. So this is how you would recognize the two differences, because you must identify that, because once again, there are different rules. Okay, so in equations with fractional indices, you can see that your index is a normal fraction and that your variable is in the base. And again, you must solve for x, meaning you must find a number value for x. Okay, now step 1 is to get x on its own on one side of the equal sign. So you are basically going to change the subject of the formula, which once again we do by doing Goro is O. Okay, so we want to get rid of the 4 because we want the x on its own on the one side. So you will take over the 4 by doing the opposite operation, which is divide by 4. So that will give you x to the power of 2/3 equals 9/4. Okay, now the law for solving this is to multiply by the reciprocal of the fraction. So you will just simply multiply the left-hand side by 3/2, which is the reciprocal, and you will multiply the right-hand side by 3/2, because remember, once again, you must be fair. What you do on the left side, you must also do on the right side. So now when you got a scientific calculator, people, you can just simply put 9/4 into brackets and then to the power of 3/2. And that, in fact, will give you an answer of 27/8. But since I have taught you in the previous videos to always find the prime factors of your basis, I will now go and explain the longer way, which is factorization of the basis. So if you take the 9, that becomes 3 squared, and the 4 becomes 2 squared, right? And then you have that to the power of 3/2. Now remember the law of a power to a power. Then the numerator becomes 3 to the power of 2. Then we multiply 3/2, and the denominator becomes 2 to the power of 2, and we multiply the by 3/2. Remember, a power to a power, we multiply the index. If you do not know these laws, please watch the video on the basic laws of indices. That is where I explain it nicely, and where I also explain how to move this law. Okay, and then if you look at that, 2 times 3/2, we can actually cancel the 2, which gives me 3 to the power of 3. And here we can cancel the 2 and the 2. Remember, it's over 1, or you just simply put that into your calculator, and that gives you 2 to the power of 3. And 3 to the power of 3 is 27, and 2 to the power of 3 is 8. So that is the long way, where once again you take your base and factorize that, put that into its prime factors, so that we can do more easily the multiplication law of power to a power in this case. All right, then if we look at the next example, this is a bit more complicated. Firstly, you must recognize that as a quadratic trinomial. And this becomes complicated because it's not just simply a square and then a x squared and a x. It is x to the power of 2/3 and x to the power of 1/3. But I want to take you back to what I taught you about addition and subtraction of common fractions. If we have 2/3 and 1/3, then remember those are both humans. So for this case, you can basically ignore for the beginning the denominators, and then you would recognize the squared here and the power of 1 there, and that would make it easier to recognize that as a quadratic trinomial. So in this case, people, we have to factorize because we've got a 0 on the right hand side and we have to solve for x. And a quadratic trinomial we factorize by the A1, A2, B1 or B2 method. Again, if you don't know what I'm talking about right now, then you haven't seen the videos on factorization of quadratic trinomials. Please watch these videos. These are 4 different videos called Factorization of Quadratic Trinomials A1, Factorization of Quadratic Trinomial A2, and so forth. But to make this easier and not to work with fractions, we are now going to say that x to the power of 1/3, x to the power of 1/3, I will make k, which then also concludes that x to the power of 2/3 is k squared, right? We take that as a constant, so you can make it a capital K if you like, then it looks a bit different, okay? And that enables us to, for now, not work with the fractions. So we're going to rewrite this as 3. Now remember, x to the power of 2/3, we made k squared. And then minus 2, and x to the power of 1/3, we made k minus 21 equals 0. Okay, so we assume that x to the power of 1/3 is k. That's why now instead of x to the power of 1/3, we write k. And then it is concluded that x to the power of 2/3 is k squared. That's why we made x to the power of 2/3 k squared. So if you now look at this, 3k squared minus 2k minus 21, then this is quite easily factorized. Okay, we've got the negative c and the negative b. In this case, it is a b1. So let me factorize. This becomes 3k plus 7 and 3k minus 3, right? But now we must go back. We must reverse this, okay? And look here, since we made k, or x to the power of 1/3 k, then into our brackets, we must now again exchange the k with x to the power of 1/3 plus 7. And here we're going to exchange the k back with x to the power of 1/3 minus 3, and that equals 0. So now we go on like normally solving a factorized equation. So we have now, as I taught you, a times b equals 0. That means that either a plus 7 equals 0, or 3x to the power of 1/3 minus 3 equals 0. And once again, people, we've got a normal linear equation with one unknown. So we're going to solve it by using Gr10 or. Move the 7 over, which becomes negative 7. And on the left-hand side, we've got 3x to the power of 1/3 left over. Then we're going to move the 3, which becomes divide by 3. So then you have x to the power of 1/3 equals negative 7/3. Okay, and now as we will remove this fractional index by multiplying with the reciprocal, okay, then be fair, multiply by the reciprocal, then we have got x to the power of 1/3 times 3/1 gives me x to the power of 3/3, which is x to the power of 1. And if you put this negative 7/3 to the power of 3, you don't really need the over 1. Your answer will be 12 and 19/27. So this one is more complicated, but it is just we're using a way that makes it easier for us. So we do need to recognize this as a quadratic trinomial. The way you can do it is by ignoring the denominators because they are the same. You can only ignore the denominators if they are the same. And then you get 3x squared and then minus 2x, right, and minus 21, which then indicates to you that it is a quadratic trinomial. Then to make the whole process of factorization easier, you will take the x to the power of 1/3 and you will say, I for now make it k, which stands for a constant. And therefore x to the power of 2/3 will become k squared, right? And then if you have exchanged these, right, then you can very easily recognize the quadratic trinomial, which we then factorize. In this case, it is a B1 factorization. And now we need to exchange back the k's. The k represented x to the power of 1/3. So instead of k, you must write x to the power of 1/3. And in this bracket also x to the power of 1/3. And then we just simply going to make the one bracket equal to 0 or the other bracket equal to 0. Right, and then you solve it by simply doing Gr10. So when you now look at this one and you have done Gr10, then that x will give you 27. Please let me know when I have to do more videos on this. I hope you understand and have some fun with it.